Hi Prof, I'm Jonathan from Group P1-9. So now I'll be explaining the coding implementation for our project. So we first start by importing the necessary libraries and functions for the code. And then we go on to the data pre-processing and preparation. So we start by importing the raw data and giving them the respective headers. And then we find the averages of some of the columns and we drop the unnecessary features. So we do the same thing for meter C and D. So next we remove any negative or zero values in our data set. And then we check for the relationship between the meters. So for meter B and C, you can see that the correlation between the two meters are there's a lot of unrelated features. So same thing for meter B and D as well. However, for meter C and D, there's a high correlation between all the features. So we can more or less say that meters C and D are related, but B are not related to the other two. Next, we check for the covariance between the various features to the classes. And we find out that symmetry and cross-flow has a very little importance to the classification, so they are removed as well. Next, we define the features for us to standardize the data. So we standardize the data for better distribution as well as prep it for PCA analysis. So here we run the PCA analysis for all the meters to 2 to 3 principal components. And then after finding the principal components, we add the class back into the final data frame. And then this one, we just remove any null values that may have been created from the PCA. So next, we split the dataset into X and Y for classification. So 1 is for meter B, 2 for C, and 3 for D. And then we split the dataset into training and test data according to the 80 to 20 split. Then after splitting, we move on to the classification. So we run the classification for all the meters for the various classifiers as well. So we start with KNN for meter B, and KN for C, and KN for D. And then we move on to naive Bayes for B, C, as well as D. And then next one is the log regression and linear SVM for B. So the results is here. C, as well as D. And then next we run non-linear SVM for B, C, and D as well. And lastly, artificial neural network for B, C, and D. So with this method, we can actually find the best parameters for each of the classifier. So for example, for artificial neural network, we see that 61 hidden layers gives the best results across all 3 meters. So we compare these accuracies of all the classifiers with their best accuracies in a separate table, and then we find that artificial neural network and KNN gives us the best predictions. So to further find out which is final classifier we want to use, we use visual inspections. So we first inspect for meter B. So meter B with a KNN of K equals to 3, and ANN for meter B with a hidden layer of 61. So from these two, we can see that actually ANN has a much better clustering and separations between the classes. So one thing is for meter C, we didn't plot it because there are 3 principal components, so we cannot plot it on a 2D plot. So next also we run the comparison for meter D. So for meter D, with KNN equals to 3 and ANN equals to 61, we see that actually there are still a lot of random clustering between both of them. However, with the accuracy and the meter B results, we choose that we show that ANN is the better classifier to choose. Additionally, all this random clustering may be because of overfitting in the ANN. So we reduce the number of hidden layers for the ANN to 60, and we see that there's actually a lot better clusters form and separation between the classes. So this number of layers are used for our final classifier. So we define our final classifier, which is ANN with a hidden layer of 60. From the final one, we just show our final accuracy score here, and then we also show the error, so the RMSE for all 3 meters, and then we plot the confusion matrix. And then lastly, we show the classification report for all meters, where you can see the precision, and we can break down which classes are predicted the best for the classifier that we chose. So that's all for our code. Thank you.